Hi and welcome to Sqizz.com, the connected marketplace. Today we'll be looking at the changes we've made to the Sqizz.com connector software in the 1.19 release. The Sqizz.com connector is a free piece of software developed by us that allows a business to connect any of its business software, databases, spreadsheets and files, storing data into the Sqizz.com and Todex platforms, allowing businesses to save and make more money by automating data management and transfer between its systems and other supplier and customer systems. Now you understand what the connector can do, let's look at the changes made to the connector in the 1.19 release. This release adds 3 new features, 17 improvements to the connector software. It adds the new ability to import and store supplier invoices within the connector, allowing invoices for purchases raised against suppliers to be automatically imported into business systems via the connector software. This is based initially on using the generic adapter within the connector to import these supplier invoices through supported ODBC, ADO.NET, SQL-like database connections, as well as CSV files or JSON or XML web services or file transfer methods. Additionally, a new preset has been added to the connector's generic adapter to allow the connector to integrate with Micronet's Harmoniq system. This preset configures the generic adapter to talk to Harmoniq's SOAP-based web servers for reading and writing data to it. The preset provides all the necessary configurations to allow a business to set up its data in Harmoniq and have it seamlessly be synchronized with e-commerce platforms via the connector. This release adds 10 new JSON and XML field functions that allow all data retrieved by the connector's generic adapter to be manipulated in different ways when the data is coming from JSON or XML-based web services or files. These functions are very similar to SQL database functions, but are instead being able to manipulate data stored in JSON and XML data structures. Within the connector's generic adapter, there is now the ability to generate documentation in a web page form that shows all the configurations of an adapter in an easy-to-read format. This makes it much easier to see how a generic adapter has been configured and share that configurations across any devices, small or large, that can read web pages. Additionally, this release adds a number of new settings to the generic adapter's data imports and exports to give more flexibility when needing to write data to JSON or XML-based web services and files. Plus, there's a number of other small improvements made to multiple adapters in this release. If that's not enough, follow the Sqizz.com YouTube channel to keep up to date with all the latest features we're releasing, and sign up and follow the Sqizz.com connector feed to receive announcements and discuss connector topics. In the connector's 1.19 release, we've added a new feature to the connector software to be able to import supplier invoices to the connector, then allow those invoices to be imported into accounting and ERP and other business systems through the generic adapter by default. Within the connector application, there is a new tab that now appears in the list called Supplier Invoices, and this will list all the invoices that have been imported into the connector from external systems, such as the Sqizz.com platform. And this allows invoices from an organization's suppliers to be retrieved or sent through the Sqizz.com platform and then sent across to the connector software, where it can then be imported into the relevant business system that is configured with the connector. So if we look in this tab, in our example here, we have 4 invoices that have been imported into the connector. We can see that they're invoice numbers. We can see the account, so that would be our supplier, also known as a creditor within our accounting or ERP systems, and then how much those totals are for, how many lines there are, and whether or not they've been imported successfully into those systems or not. So from here, we can also click on the invoice number to view the details of the supplier's invoice. And in here, it is very similar to how sales orders and purchase orders looks, where we get a whole bunch of different information about the invoices, such as the invoice numbers, supplier's invoice codes, sales order numbers that may be relevant against. We've got information about the supplier account from our own system and all the details about that. Any pricing, payment data, such as how the invoice was paid for, any freight information to do associated with that, such as carrier information and tracking codes, and any other location data that is relevant to this invoice. Additionally, we've got the addresses where the supplier has delivered and billed the ordered goods and services to, as well as we can look at the lines. So in this example, we have a number of lines, a couple of text lines. We have a product line, which is buying some green paper, and then each line has pricing information, dimensions of that product if it's available, location information that references back to the original sales order, the original purchase order, and the supplier's invoice. So that's how we can then correlate this invoice back to other data that it has been derived from. We've got some general ledger codes that can be assigned against the lines, as well as kitted stuff. We've got taxes, so if there was any taxes applied against the line, so in this case we've got a GST or goods and services tax applied against it and the amount, and any other information such as comments against the line. That's what this attribute information is all about. Additionally, we have surcharges, which is very similar. So if there was any credit card surcharges or freight surcharges that applied against this invoice that the supplier set against this invoice, you can see that information there, as well as the taxes applied against those surcharges. So there's a great amount of detail that is available when looking through here to see all the different information that is available about the supplier invoice. So back within the connector supplier invoices list, we've got a number of searching capabilities. So we might want to search on invoice code. So if we type in 125, click search, you can see that it will narrow down the invoices that have been stored within the connector software itself. So we've got a whole bunch of different filters in which we can search for invoices for if we need to do some diagnostics to see if invoice is imported the way it should have. We've got a number of tools that are available here. So if we had a lot of invoices, we could paginate through that list of invoices. We can refresh the list as invoices come in if we need to. We can mark invoices as being already imported or not imported. So if we click that, then those invoices will be marked in green to denote that they have been imported into the configured adapter. We can also remove invoices from this list. So we can remove all supplier invoices that are already been imported, or we can remove just the selected, just like that. We can also try to attempt to re-import invoices or import them for the first time by clicking on the import button, as well as we could try to import all supplier invoices that are in this list that are not marked in green as well. The other new features we added were to the generic adapter. So if we look at these supplier invoices assigned to the donut factory adapter, so if we go into that adapter, my example I have here in the data imports list, there is now a list of all the different imports that we need to use in order to import one of these invoices. So by default, we need to have the supplier invoices import type selected and configured, and all these other imports are optional. But if you want to get, for example, the lines assigned against the invoice import into your system, then you will need to assign it to a data source and configure it up. So let's take an example. I'm going to get out the supplier invoice data. Now, in this adapter, I have already set up a CSV file data source type. So what that will do is it will save the data to the directory that I have configured up here. So if I then go back into here and assign it to my CSV export, I just need to specify the file name that the supplier invoice will be saved as. So it naturally makes sense just to put it in, call it supplier invoice. And we've got this hook where we can put in curly brackets and a hash number, and that will put the ID, the unique ID of that invoice, its number into the file name. So that way we have unique file names when they're being imported, and we'll put the extension as a CSV file extension. Now in the data fields, this is where we get to choose what information we want to be embedded in our CSV file and what is the name of its column within the CSV file. So we might not want to call it billing contact. We could call it billing address contact, for instance. That is entirely possible. And then we need to just go through the fields. Now I might just to make this quicker, I might just do a big copy and paste and activate all the fields that I want data in this CSV to appear as. So we'll get some delivery information as well. Also turn that stuff on. We might want to know the invoice number. So we'll put the invoice code and its number also into our CSV file. As you can see, there is quite a lot of fields that are available for a supplier invoice. So it is quite detailed. We might want to know some dates, such as when it was sent or when it was modified. So we would continue going through this process to work out the data that is relevant to the CSV file, and that file may be relevant because it needs to be then read in by another piece of software. And so with that all done, with our settings now saved, reload those data fields. Now with that all configured up, if we go back into our supplier invoices, we should now be able to import these invoices, which will create the files on our file system in the CSV file format. So that now has been imported from the connector's perspective. So if we now go to the directory on the file system, so we can now see on the file system, we have this file here called Donut Factory Supplier Invoice 2. So if we now then open that up in a spreadsheet editor, so I'm using LibreOffice, we can now see all the information of the fields that we had selected and the data in the corresponding second row, since the first row is a header row that tells us the name of the columns. So there's an example of how you can have supplier invoice data put into a CSV file format that can be then imported into relevant systems. Now, it's not just related to CSV files. We can do that for all the different types of data sources that the generic adapter supports. So we could get the supplier invoice data into an SQL server using SQL queries. Same with ODBC and SQLite databases, all using SQL. We could import it into a e-commerce standards document-based web service, or we could also put it into the JSON or XML file formats, and we could save them either to the file system, or we could then push them across into web services across the internet or within our own internal network. So using this functionality, it now makes it possible to automate invoices coming from suppliers, organizations, to be able to import those invoices back into our own systems, so that way we know how much we owe to our suppliers, and then we can then make payments against those suppliers and record them in our general ledgers or our accounting systems, so that way the money is fully tracked, as well as the stock is tracked as well, since the supplier invoices indicate the quantity of stock that has been delivered and the kinds of products that the supplier has confirmed. So there is a lot of data that is available within the supplier invoices, and this functionality can be used in conjunction with the Sqizz.com connector to automate and save businesses a lot of money when they're dealing with suppliers, if the suppliers are also integrated into the platform as well. Within the connector 1.13 release, we've added a new preset into the connector to allow it to integrate with the Micronet System Australia's Harmoniq software. Unlike new integrations where we normally create a completely new adapter for this integration, instead we're using the new preset ability in order to configure the generic adapter to be able to do this integration work. To get the integration set up between the connector and Micronet's Harmoniq software, if we click on the generic adapter and we'll give it a name called Harmoniq, and we add that to the list. In our Harmoniq generic adapter here, if you look at the adapter presets, there is now a preset available for the Micronet Harmoniq system. So if we click on that and click on the load button, accept that we want to load in this preset. Within the adapter preset data hook settings, we can set some defaults on how this integration is going to be set up. So a couple of questions that we have is what we should set the default payment terms. That is the payment terms which is used to work out for each customer account when they need to pay for invoices by. So by default, the default value for that is GND. That stands for a given number of days. Now this value may need to change depending on what is the default for how Harmoniq has been set up. Whether or not its default payment terms are based on a number of days before an invoice needs to be paid for by the customer, or it's based on other terms. So there's either two values you can set it. You can set it a given number of days, or a number of days after the end of the month is the two different types of payment terms that Harmoniq specify. And so what this means is that within Harmoniq has no specific payment term set against its account. It will revert back to the default of the system settings. So if the default of the system of Harmoniq is to say that invoices must be paid after the end of the month on a given date or day, then that's when you would put this value in. Otherwise, you just set it to give a number of days, such as a 30 or 60 day account. So the second setting we have is whether or not, what is the default action if an account is being marked on hold, or that no ordering is no longer allowed for. So if this value is set to block, then the customers that are ordering with that account will no longer be able to place orders. They'll be blocked from placing those orders. But you may not want that behavior. You may want to just warn those customers if they're gone, if their account is on hold, but they're still allowed to create orders, or if you only want them to be allowed to create new orders by paying for those orders up front using credit card, then you set that value to warn CC. Or if you don't really care if their accounts are marked on hold and you still want it to allow them to create orders regardless, you can put the value to off. So generally it's best to set that value to block, and at any change you can change all these settings within once the adapter has been configured. The other part that we need to know about is where is the domain or IP address of where the Harmoniq web service is installed. So this connector will try to talk to Harmoniq's SOAP-based web service, that is what it's called, in order to read and write data from the Harmoniq system. So when Micronet installs the Harmoniq software, they need to set up a web service that then this connector can then talk to. So where you install the connector software depends on what this host or IP address. So if it's on a computer which is in the local network of where Harmoniq is installed, then there might be a 192.168 kind of IP address. But if it is then made available halfway across the world, then you need to have a public IP address that points to the network and computers where that's installed. So that might be some kind of public.example.com website that you would put into here. So by default, if the connector was installed on the same machine as the Harmoniq web service, then this value would most likely be set to localhost. Now the other part is the protocol. So depending on the web service is hosted over a secure connection, that is a HTTPS connection, then you'll change the protocol to that. Otherwise, if it's running insecurely, such as on a local machine, then it most likely will be using the HTTP. So if that web service is hosted halfway across the world, generally it needs to be secured to make sure that any data coming to or from it is securely encrypted and decrypted to make sure that other people can't read it. But if it's being run on a local machine, then you typically wouldn't need to worry about security, and you'd leave the protocol to HTTP. So once we've got those settings configured up, those defaults, click the save button. You'll get a dialog saying that the preset has been successfully loaded. And what we can see here now is we've now got two data source types that are set up. One to be able to talk to the SOAP-based web service of Harmoniq, and another one to just read data locally within the adapter itself. So what this has been able to do, if we go into the data exports now, we'll see now that a number of these exports have already been configured for us. So we don't have to worry about setting up all the defaults of the generic adapter. You can pretty much just start plug and playing with this preset once the connectivity has been made. So it's as simple as that on how to set up a integration between the Micronet Harmoniq system and a generic adapter within the connector. Now in the future you may need to make some changes to this. So for example, I was talking about these web service settings. So if we go into modify, within here we can see where those settings were to be able to set the protocol, to be able to set any additional information about how often we should allow connections between Micronet to last for before we give up on them. If we go into other exports, we can also see there have been decisions made on what's the most appropriate place to read data from the web service that Harmoniq provides for its product data. So in the future, you may want to then tweak this. You may want to go in. You may want to do some changes to see which fields are mapped. That is all possible. You may want to do some replaces or put in some if conditions, or even turn on some other fields that we haven't turned on by default. That is all possible, such as you may want to set a fourth description for a product, or you may want to set brands based on other data that's available in the web service. That is all possible from within this generic adapter. So it allows a lot of flexibility, but you're already starting off with a very good basis on a complete integration just by loading up that preset that we've made available. And over time, we may update this preset as more data comes available through Micronet's web services, or if they make change to the Harmoniq web service in the future. Within the 1.19 connector release, we've added a new feature to the generic adapter to be able to generate out documentation on how a generic adapter is configured. So if we take our last example where we talked about the Harmoniq adapter that we just set up, if we click on the settings button against any generic adapter, within the generic adapter settings window, if we go to the bottom of the window, we can see that there is a new button that appears now called a generic adapter documentation. So when we click on this button, what it will do is generate a web page that will contain all the configurations of our data sources, our data exports, and all of our data imports that we have available, and put them all into a single web page to make it nice and easy to be able to read how this has been configured. So if we go through that, click the button, it will ask you where do you want to save that web page to. So we'll just put it in the location that I have available here, and I'll just call this Harmoniq adapter doc, and click the save button. So it will save it as a .html file, which is a web page file. We'll click the save button. And so what will happen is once the web page has been generated, the connector will open your default web browser, and then you can go through and then you can start looking at all of the documentation that has been available. So that at the start of the documentation, we have a table of contents. So we can see all the data sources that have been configured for that adapter. We can also see all the data exports, and we can see the data exports that have been assigned to a data source and the ones that have not been. So any data export that is grayed out here, saying that we we have not assigned the data source to that data export, and there's no ability to get that particular kind of data out. So we can see here the adapter status data export has been configured, the categories data exports as well as categories products, but there's a lot of them, the combinations ones that haven't been touched, and we can see all the contract ones and all the other exports that are available here. So that's the equivalent if we were going back into the connector and we went to the data exports to go through and see, once we selected a data export, to see whether any data source was available to it. So if we keep scrolling down through the table of contents, you can click on any of these in order to take you to the section that describes the configurations of that given data export. And if we keep going through, there's also a section for the data import, so we can see a lot of sales order imports have been done for this Harmoniq adapter. So once we go through there, then we get into the details of each of the data sources, how it's been configured, what the options or what each of the settings in the data source are being configured as. So in this example for our Micronet Harmoniq SOAP-based web service data source, we can see that here's the protocol, the URL, the HTTP request headers to be able to control how the querying to that web service is done. And then we get into the data export section. So we can see here for the adapter status data export, we can see which data source it is configured to. So in this case, it's using the SOAP-based web services. What URL, in this case, it's relative URL, is it calling in order to get, example, it's using the tax rate endpoint from the web service in order to check to see if the web service is actually up and available. So that's using a web endpoint that returns a very little data, since we don't need to get a lot of data to be able to work out if the web service is running or not. And then we've got all the other properties that are available for this export based on the settings that the data source makes available for it. So in this case, we've got for a JSON or XML based web service or file data source type, we can see the request content. So that's where we're dealing with a SOAP-based web service. So here's what the request data is looking like in that request, and how we check to see if a good response has been returned from the web service. And after that, we can see all the fields that have been mapped for that one export. So if we go into an export which has a few more fields, so categories for instance, so once again we can see all the information about that. And then in the data fields we can see which fields have been turned on, which have been made active, and what they've been assigned to. So the category code has been assigned to the web services. So this is the product category web service endpoint, and it has a field called a:code, and that's been where we are finding our category code, and we're using the description field within the web service in order to obtain the category name. So you can see there's a translation where in Harmoniq a category's name has its field called description, and we can go on and see which other fields and where configurations are being made for these field mappings. So this, by going through this documentation using the table of contents, we can immediately see what is the configurations of an adapter, making this both very useful to quickly understand how an adapter has been configured, but also we may want to save this web page and we'll share it around when we're passing around the presets, so that way it makes it nice and easy for everyone to be able to understand what the configurations of a given adapter are. This should make it a lot easier and a lot quicker to understand how adapters are configured. In the Connectors 1.19 release, we've added additional improvements to the generic adapter when a JSON or XML-based web services file is assigned to data exports and data imports. So if we have a look at this, once again, we'll use our Harmoniq adapter, which we set up previously, to show these new fields that we have available. So a new field that we now have available is this field called HTTP request headers for the JSON XML settings. So what this field allows us to do is on a per data export or data import is set the request header specifically for that import. So we can have an example here where we have a SOAP-based web service, and for every call that we make to a different web service, we have to set different headers, HTTP request headers, in order to tell it what data we want to retrieve out. So in our example here for getting adapter status, we're going to get out the data from the tax rate endpoint to be able to make a connection and see that it is active. And so we can see we're in the headers, we need to specify what is the endpoint name and then the data that it is looking to retrieve there. So if we look at this and we go to different exports, so let's look at the categories, you'll see that the headers are able to be changed for on a per export basis. Previously, to do this, you would have had to set up separate data sources for each of the different headers that you are looking to to modify. So if we have an example like this, if we go into the web service, you can see by default the headers here is some accepting encoding. So we're saying we're allowing for compression when the web service returns results, as well as we're setting the content type to be text/XML. So previously, we were limited to setting all the header information within the data source itself. Now what it will do is it will get all this information set in the data source as well and append that to the data that is set in the request header here. So for this product category data export, it's going to put in both the headers that have been set here against the data source, and it's then going to add any additional headers that are set in this field here to generate the final list of headed information that is sent off in these HTTP requests. Now, another improvement we also added to the generic adapter, if we go back to the general and look in the data source types, for the JSON XML web service file, there is now the ability to set the protocol here, and that's what governs how we make connections to retrieve the data. There is now the ability to set not just HTTPS or HTTP or file, there is now the ability to set content body. So when the protocol is set to this word content body, what that will tell the export is not to make a request over the network or not to try to retrieve a file, but instead get the data from the body of the actual data export. If we go into data exports, and for this Micronet Harmoniq adapter that we've set up here, we can see in the price levels here, we've now assigned it to our other data source type, which has the content body protocol. And what we can see here is that the data for this export is now available in the body of the HTTP request that we've got set here. And what the adapter will do instead, rather than trying to make it a request over the network, it will just read all the data from this body here, and then it will process the data there. So that's why we don't need to set any URL, we don't need to set any headers. The HTTP request method is ignored. The adapter will simply read the data from this field here, and then parse that using the results here, and then it will read the data from the field mappings that we have here. This improvement does is it avoids us having to instead put this data into separate files and separate locations on computers. Instead, it can be all self-contained within the adapter, which makes it very good for we want to save this adapter as a preset. Then all that data stored here will then be copied into the preset file where it can be passed around and then redeployed into other locations. So that's the typical use case of why you would set up this separate protocol, so that way you can embed the data directly within the adapter's configurations itself. Within the 1.19 connector release, we've added a number of improvements to the generic adapter and the JSON XML query browser to be able to query and extract out data from JSON or XML based web services and files using additional field functions to be able to manipulate the data that is being retrieved. So we can see an example of these new functions. Here's a list of all the functions that we now have available. So we have now a trim function, a record index function, array length function, parent array index, record set index, page number, datetime now, encode, decode, and parent node. So I'll show you now how each of these functions works when you would most likely use these functions when you want to export or import data to JSON or XML based web services. So within the connector, if we go into the tools menu, we can use the JSON XML query browser to play with these functions. Within the query browser, I've got some data that I've set up within my file here. So I've got some JSON data here that has a list of products. Then within each product, we can see some product code, names, descriptions. We've got a list of prices, and then we've got 4 products that are available in this list. So we'll grab all this JSON data for our test for demonstration purposes, and we'll paste that into the raw data tab of the query browser where we can then read from. So the first thing we're going to need to do is set the JSON record set part to tell us how to find the records within the JSON data. So we have an array of products within the JSON data. So first we'll get all records that are within that array. And this is when we can use the first JSON XML field function is called the trim function. So if we use that, put the name of the attribute within the trim function, what will then happen is that you can see that spacing has now disappeared. So the trim function accepts at least one argument, which is the name of the field or the literal text that we want to then remove white space from. The second argument is optional, and it can be either the value left, right, or both. So maybe we want to remove the white space on the right side of the name that is appearing here. We only want to get rid of that space, so we'll put the word right in there. And when we run that, we can see that the space has now been removed from the right hand side. And if we do it the other way and we put the word left, then it will remove only the white space on the left hand side of the values given. So if now look at that, the white space is now being removed, but it still exists there on the right hand side. Now we can also put in both as an argument, and that will also remove white space, but if you're going to do that, you most likely won't need that unless you want to specifically say put the word both in to make it crystal clear what you're trying to achieve. It's a very useful function in order to clean up data that may be left behind from these web services. The next function we will look at here is the record index. So if we then put that into another field, so the record index function can accept 0, 1 arguments, and what its purpose is to do is to return the number of the record that has been retrieved from our record set path and then within our data. So it basically allows us to put in the numbers 0 to 10 if we were getting out 11 records. So we can just call that a record number. So when we run that, you can see that the first record that is being retrieved from our data, this function will return the value 0. For the second record, it returns the value 1, the value 2, and value 3. So it's basically a way to number our records as they are retrieved from the JSON data. Now there is an optional argument that we can add to the function where we want to offset the number returned by it by a number. So if you put in literal text and put the number 1 and then run it, what it will do is add 1 to every single number that was previously returned. So for the first record, it was previously returning 0, but then it's done a calculation, say 0 plus 1 equals 1, and 1 plus 1 equals 2, and so on and so forth. Now we could then put the number 10 there if we wanted to, and you could see that all the numbers are then, the record index starts from the number 10 as opposed to the number 0. So it is a helpful argument if you need to return the numbers of the records that are currently being processed. Now what you'll notice if you do a union, so if we just do that and then we return the same data again, you can say that the record numbers will continue going down across the entire results that we have retrieved. So they will not start back at 0 again for when we get the same product records out. Now the next function we'll be looking at is the array length function, and what this returns is the number of elements or records that would exist within an array. So if we have a look at our data here, in the first product record we have this array which contains an array of descriptions, and we may want to know how many records appear within this descriptions array. So to do that, we put in the array length function. Now it accepts 2 arguments. The first one is we need to provide it the name of the attribute that is storing the array. So we have it here called descriptions. And the second argument says how many steps should we go up the JSON tree to find the descriptions object. So if I put in the value 0, then we can see in our product's record set path, it's going to find the record here, and then from there, it's going to go up 0 steps in order to then find the attribute that contains the word descriptions in it. So we'll call that our description array count. So when we run that function, we can now see that it has been able to find 3 description objects that appear in the descriptions element. And then for the last 2 records, it returned the value -1. So if we look in our data here, we can see in the data here for the last 2 records, there is no descriptions attribute. So in the first object, it's been able to count out these 3 records. And in the second one, it's been able to do the same with 3 records, but it has found no descriptions attribute. And so instead, this function will return the value -1 if either the object that is found is not an array or the object does not exist within the data. And that is what is happening here. This function can also be used to work out if a data is being stored in an array or an object within the records that you are retrieving out. Now, what we may want to do is find an array further up the chain. So we're starting off at the product record, but we may want to know how many records are within this product's array itself. So we can tell it to go up instead to the products record. So what we need to do is tell it how many steps we need to go up from the record that we're currently processing. So we're starting off at here. Now the first step gets us to the array level of that object. Then the second step gets us to the object that stores the array, and then the third level gets us up to the parent record that stores this product's record. So we actually have to go up 3 steps in order to then find how many records are within this product's array. So if we run that, now I've missed a literal character there, so that's why we got an error. So if we run that, we can now see that for each record, it is returning the value 4. So that means for each record, if we're in the second record here, is going up 3 steps and then finding this same products array and then counting how many records are within it. So there are 1, 2, 3, there are 4 records within this products array, and it's being able to do that for each record that is returned by our record set path. So that shows you an example how you can use this array length function to be able to step up through your JSON hierarchy or data tree structure to find the counts of how many objects within arrays that are further up the hierarchy. Now, from there, you can also go the other way where you can step back down. So maybe within the products array, we may want to find how many pricing records are within the second object. So we can actually go back down the chain here. So we can say for the second product object, we want to then find within its prices array how many prices it has. We may want to go up from the products array, and then we may want to go back down to the second product record and then find how many prices are contained within that object. So if we do that by putting the product name and then we put in the square brackets, put the number 1, so that's the second record, since the first record would be the number 0, and then within that object we're saying how many records appear within this pricing array here. So if we run that, we can see that the value 3 gets returned. If I then remove one of those records and then run it again, we can see now the value 2 is returned. So that highlights how you can step both up the JSON tree hierarchy to find arrays further up, but then you can step back down the hierarchy to find objects and to find the number of objects that appear within arrays. And that may be relevant if you do need to go further up and down JSON data, depending on where data is available and stored. Now that leads us into our next function, which is called parent array index. And what this does is it allows us to find the position of an object relative to the parent array which an object is stored within. So in our record set path, we're getting out each product record, and we may want to know the position of that record relative to the products array which is above us. So if we put in this function, the parent array index, it accepts one argument, and that's how many steps up the chain should we step up to find the position of the closest array, if it's at 0, or an array of a parent object within the JSON data. So let's just we'll call this one array index. So when we run this, we'll see the numbers 0, 1, 2, and 3, because what it's doing is getting the first record out, and then it's going within the parent array, what is the position of that, and that is at position 0. Then for the next record, it will then find its position, which would be position 1, 2, and 3, and so on. Now let's make this a little more complicated. Say we, instead of wanting to get out product data, we wanted to get out product pricing data. So let's just change this to get out a list of price records. So it's going to go into each product record, into the products array. For each record there, it's then going to go into the prices array and get each record there. And then we may want to return the price of the product, of that price, as well as we might want to return the product code. Now the product code does not exist within this object that we are now doing. So we need now use the existing parent node function. And so we want to get at the parent node, and that we need to go 3 steps up in order to find that. So now when we run that, we can now see that for each product record, we are now getting out the 3 prices that are available. So the price is 10, 8, and 6, which are appearing here, 10, 8, and 6. And we can see that we're getting the pricing records for the same product 3 times. And then for the second product also has these 3 prices here. Now, as you can see in the array index, it's returning the value 0, 1, 2, and 0, 1, 2 again. So what is happening here is that because our record set path, we're starting in this prices array, it's going for the first record, what is its index within the prices array. So this first record is at the index 0, the next one is at the index 1, and the next record is in index 2. Then after it's found those 3 pricing records, then it goes on to the next product record and does the same for its pricing records. So we can see then it's going through these same pricing records and doing the same. So if we had a 4th product record at 50 cents, Then when we run that, we can now see that we have the 50-cent price record for that nut product, and that we're getting the third index array value that is there. So this is useful because if we look in our pricing data, when we're pulling out pricing for products, we may want to know the price level ID of a product. And as we can see in the data here, there is no price level, or what is called the key price level ID. Now, if the data coming out from the JSON data is always storing the pricing records in an ordered fashion, so the first price record may be price level 1, the second price record may be price level 2 and price level 3, then we can use the parent array index function in order to then create that data where it didn't exist in our JSON data. So if we did that, we could even use a concat function to then put in a suffix. So we could call this price level, and then we'll get in the number from this parent array index function. And then when we run that, we can see that we are now getting the data for price level 0, price level 1, and price level 2. Now the price levels may start at 1 and go up, so then we could then use a calculation function then to add the number 1 to that. So we just put in a +1 here within the calculation function. Then when we run that, we can now see our price levels for our product prices now start at price level 1, 2, 3, and so on and so forth. So this is just one example of how you can use the parent array index function in order to create data that does not explicitly exist within the JSON or XML data that's being returned. Now the next function that we have available is called the record set index function. What this function does is return a number specifying the index of the record set that's currently being processed. So if we just go back to exporting out product data again, so we'll just export out the product code. So there's our data again. If we're getting out multiple different sets of data of one JSON document, we may use the union query. And then we can see that we're going to get the same product data, in this example, out twice. Now we don't have to do it this way, we could do it many different ways. But we can now see that we've now got 8 product records getting generated out as to 4. But we may want to know the number of the current record set that is being processed. So that's why we use this record set index function. It contains no arguments. So we call that record set number. And then we run this, you can see that we're getting the values 0 and 1. So this means that the first 4 records are coming from the first result set that is appearing here. Then the second 4 records are coming from the second result set here, which is the number 1. Now you could also do the same, just like we did before, use the calc function in order to then increment those numbers to make it more easy to read. So if we did that, we're now getting, you can now see that the first 4 records are coming from that first result set, and so on and so forth. So if we added another union query, then we can see that the rest of the data, that the next 4 records at the end are coming from the third union record. So this record set index tells you which record set path is currently being executed in the data that's being retrieved. Let's look at the datetime function. So this function, it returns the current datetime in the Unix datetime format, and that means that it stores the number of milliseconds since the 1st of January 1970 at 12 AM UTC time zone. So if we run that, we can see that we get this number that shows what the number of that date is in milliseconds. Now that's useful if you need to do datetime calculations or comparisons. So this function is very useful when we put it in with the date string function. So if we put that as an argument of the date string convert function, put it as the first argument, then we can put in our format. So we may want to just get out the year, the month, and the day. And that just needs to be all lowercase. So this is using the .NET datetime format in order to be able to format how the date is going to appear from the data that we are converting. And we're saying that the data is being converted from a long, since that's what this value here, it is a long integer, or that is also known as a 64-bit whole number. And whoops, I've got my data type around the wrong way. So if we try that again, we can now see our date, the current date on which this video was made, which is the 10th of October 2018. That is that value which we were originally getting out. And let's just bring that out again. You can see that's the original number that datetime now function is returning, and that's how it's formatting it. .NET platform allows us to then format our dates in many different ways. We may want to put the days first, so then we could put a slash that does the separation, then the month, and we could have the month as a name as opposed to a number. So then if we run that again, you can now see the 10th of October 2018. We can also put in hours, minutes, and seconds. So if we format it like that, then you can see that we get the full value, and we may want to say whether or not it's AM or PM, so that's what we can use the TTs for. And now you can see it says the time which is this video has been made in the PM. So that is just one way of which you can format dates in many different ways using both the date string convert function as well as the date time now function that can feed data into it. Now that may be useful because if you get two of these numbers appearing, then you may also be able to do calculations with these. So let's just say if we get the date time now, we can actually take the current date and minus 2 days from it. So if we then put in a calc function, and so we get the value, that long integer value that's going to be returned, and we do minus it by this number here, which says the amount of days that are available. So if we then look at that, we can now see the date has now changed from to the 9th of October. So if we then did another calculation where we could say times that by 7 days, and we'll just put that in brackets to make sure that it correctly calculates it in the order we need. We can now see what the date is 7 days ago from the current date that is being processed. So that shows you an example how you can do calculations on using the datetime_now function and then format the date that is after the fact. The next two functions that we have added is called the encode and decode functions, and what these do is they manipulate text data to be in an encoded form which is relevant for when we want to store data in certain data formats. So let's see an example of how that looks. So let's just grab the encode function. If we wanted to encode the product code into a URL friendly form, we would use the encode function. So it accepts two arguments, which is the value which we want to put into it, and then what do we want to encode as text into. So we would just specify a URL to put it into the product code into a URL friendly format. So let's call it product code URL. Now when we run this, in this example the encoding hasn't changed, but if our product code contained an ampersand or a question mark or a slash character, when we run it again, you can see that those characters will have been interpreted into these %26, %3f, and %2f values. And what that means is that this value now is able to be inserted into a URL for a web page, and it will not break the URL, because normally in a URL, if you had a slash character, that would tell you it's within a directory or folder within the website, which is different. But we want to treat them as literal text, and so that's how this encoding would do it. Now, if you went the other way, if we use the decode function, and let's just take that value that we had there, and we'll put that as literal text into the decode function. This allows you to go the other way. It allows you to go from an encoded value back to its original decoded value. We'll call this the decoded field function. We'll call this one encoded. So if you run that again, you can now see the original value that this encoded value has come from. Both the encode and decode function accept a number of different encoding and decoding options. So URL is one, another one is XML. So let's just see how the XML function works. So if we had brackets or an ampersand character, you would see that they would get encoded into this format here, which would allow this data then to be placed within XML or HTML based data, which may be relevant. And the decode function would do the opposite. If we had that value there, where you can see it goes back from that format back to the other. We can use it in base 64, which is one way to encode values. So you can see that that value that we had here for bolt 123 has now been encoded into a form which only uses up to 64 different characters to store values, which is relevant typically for authentication methods when using that. We also have SQL escaping, so we may want to escape double quote characters because we're going to use this value within a database query. So the function accepts the SQL double quote. So if we had a double quote within the name, then what would happen? We can see that slash value, it would be putting a slash before the double quote character, and we can also use SQL single quote to do the same thing. So if we had a single quote character within our JSON data, it would put a slash in front of the single quote characters. And the other one that is most relevant is if we can set the Json encoding, which is similar to the SQL double quote. If we had a double quote character within here, it would have put a slash in front of the double quote. And that ensures that this value, when embedded in JSON data, is able to be embedded within it without breaking the structure. As you can see here, I need to put the slash in order for this JSON data to parse. So the encoding and decoding function is relevant for if data is coming back from web services in a different encoded form, and you may need to decode it, or opposite, you may need to put values into the request data for JSON or XML web services, and you may need to encode values to ensure that they don't break the XML or JSON data. That's typically the use case that is going to happen using these functions. The next new function we have is called the page number function, and what this returns is a value of the current page of records that are being requested. Now, if we use this function within our JSON query browser and it accepts no arguments, it's always going to return the number 1, because we can only get one page of records from the file or raw data or the web service that we're querying data from. To see this function in real action, we need to configure the connector to be able to show how multiple requests can be made to a web service to retrieve multiple pages of data, and then when each page of data is returned, this page number will change in our record set. So if we do that, I've configured a generic adapter here that is going to make a request to the Sqizz.com API or web service in order to retrieve some product data. If we look into our web service here, one of the settings available for the HTML JSON web service is to say how many records that we want to get per page of requests. So we may only want to get 50 records per page. So when we do that, if we then go into the products data export, which is configured, we can see the URL that we're going to request from, and then we may want to get into one of these description fields, one in the product description fields. We may want to get the page number which was returned within. So if we put that in the 4th description field, we just put in the page number function. With our product export configured, if we go into the export routines, we want to export the product data out from the Sqizz.com platform from a supplier organization. So we find that. We're going to export it this time into a dataset. So I've created a dataset within the connector that we want to import that data into. I've called it demo, and then we run the once off button. So this will make a request to the Sqizz.com web service API to retrieve 50 records at a time. Then for each page of product records, that page number function will place the page number currently being processed, in this example, the description field. So now that that has successfully run, we can already see, if we had the debugging turned on in the logs, we can see where the requests are made to get the next page of record. So in our URL here, we're getting a 50 records per page of data from the web service, and then we're saying start from the index of 2500 to get the next page. So we can get page 51. Then if you look at the next request, you can see the previous request. So the connector is getting multiple sets of records, and then it joins them all together. Now in our example, we're importing it into the datasets. So in my demo dataset here, we can now see all the products that we're getting. So in this case, we're getting some printed data out. And we can see in our description for here is where we're using the page number function in order to get the number of the page where those records were processed. So we can see that all these records here, these were all the first set of records that were retrieved from the web service, and then the next set of records will have the page number 2, where all those records were retrieved, and the page number 3, and so on. So that's how this function may be useful if you need to know the page of the record that were being retrieved from the web service. That's when it comes in handy. So that shows you how the 9 new JSON and XML field functions work to retrieve out and manipulate data, as well as the last function is the parent node function, which we demonstrate, and it has been modified to make it easier to retrieve parent data from a web service. If we're getting out all the first descriptions of products, so we want to go down into the descriptions array, and we want to get the description 1 object. So we can just return that object, so we call that description. And once again, we don't need to change the parent node function to change the parent, how many steps we need to go up, because when it's in a negative number, it will just keep going up until it finds an object with the product code. So when we do that, we can now see that is being able to find the product descriptions for the first 2 records. As opposed to otherwise, we'd have to specify the correct number here and also define the product code that is further up the chain. So this basically, by putting a negative number, that allows us to ignore having to work out the exact number of steps. Now, if you put in the number -2 as opposed to -1, then that will say to ignore the immediate parent record and then look at the parent record above that. So if we are currently in the description1 object, it would say ignore looking at the object that it's stored within and then only look at the parent objects within it. So it allows us to basically step over a level in the JSON hierarchy to go to the next one, because maybe there is a product code stored also in objects that we want to ignore. So that's why the negative value can change based on how many steps through up the parent tree that you want to step over before looking for an object that contains the name that you specify here, such as the parent product code. So hopefully that explains in a lot of detail what all these JSON functions do and how they can help you get the data you need in and out of such web services and JSON or XML files. Of course, there is documentation on how these JSON XML data field functions work. So if you go to sqizz.com/doc/connector json-xml-data-field-functions.html, you can see all the details on how each of these functions work, what arguments they're allowed, to see examples, to learn more about the arguments which you can put into these functions. It's all available from there. Have a good read and have a good play in the query browser to see how you can use these functions to your advantage. And that's a wrap up of the Connectors 1.19 release. Feel free to sign up to the Sqizz.com YouTube channel if you haven't already. And until next time, thanks for taking the time to listen. Have fun with the connector.